Hello and welcome to this video. In today's video, we are going to see how to configure router on a stick. And then to configure router on a stick, we are going to configure sub interfaces on fast Ethernet 0.0. And then we are going to put PC1 to a separate VLAN on a separate sub interface. So one sub interface on fast Ethernet 0.0 is going to be a VLAN configured for PC1, and then same applies to PC2. So let me go to router 1 and configure the sub interfaces. So I'll go to configuration mode and I'll do configure first sub interface on fast Ethernet 0.0. So I'll do interface fast 0.0.2. 2 stands for VLAN 2, which I'm going to create later on the switch. So an IP address of 192.168.1.254, 255.255.255.0, and I'll do the encapsulation .1Q 2. Let me put the IP address back again. I had problems when I was trying to configure it. So IP address again, and I'll do exit and first interface 3, and I'll do encapsulation .1Q 3 for VLAN 3, and I'll do IP address of 2.254, and I'll do exit and I'll end. So I'll show IP interface brief. It's currently down because fast Ethernet interface is down. I'll no shut the interface, no shut, and the interface is up. So I'll do show IP interface brief. And it's currently up and running. So I'll go to switch 2, and then I'll configure our VLAN over there. So config T, VLAN 2, VLAN 2, exit, VLAN 3, exit, and show VLAN brief. And currently we have 2 VLANs active, which hasn't been assigned to any port. So I'll go to PC1 and then configure an IP address, an IP of 192.168.1.1, 255.255.255.0, and the gateway of 192.168.1.254, which happens to be the gateway on the router. And I'll do same for PC2, IP 192.168.2.1, 255.255.255.0, the 0, and the gateway of 192.168.2.254. So up and running, IP address has been configured on the switch. So 1.254 is the gateway for VLAN 1, and then 2.254 for VLAN 2. So at the moment, let's see if a ping can work. 192.168.1.254 not working because 254 is in a separate VLAN. Okay, so I'll go to switch 1 and configure the VLAN for the respective ports connecting to our client computers. So interface, let me see, I'm taking the interface connecting E0 and then E01, interface E/0, switch port access VLAN 2, exit, interface 1, switch port, access, VLAN 3. So, and show VLAN brief, and the moment they have been assigned to the respective ports connecting to our client's computers. So let's see if the ping will work. Ping not working because VLAN travels on the trunk port, and therefore we have to configure our trunk. So I'll go to 02 interface E/02 switch port trunk encapsulation.1q switch port mode trunk. The interface is up, okay, and show interface trunk, and it's working. So at the moment, what do we have here? Two sub interfaces has been configured on fast Ethernet 000 on switch 1, and then the interface connecting from fast Ethernet 00 on switch 1 and router 1, to switch 1 on interface E02 has been configured as a trunk. PC1 here is in a separate VLAN 2, which is connecting to 1.254 network, and then PC2 here is connecting to 2.254 network. And at the moment they are on separate VLANs, and they are not able, they shouldn't be able to communicate because VLANs are used for network segmentation. So let's try to do a ping. Let's ping the default gateway .1.254, and it's working. PC1 is able to ping PC2, the default gateway, which is 1.254, and let's check from PC2. So ping the gateway 192.168.2.254. Yes, and then PC2 is also able to communicate with its gateway. So let's do a cross ping to see if it will work. Ping PC2. First, let's ping PC2.2.1, and it's working. It's working because interVLAN is routing traffic from network 1.254 to the second network, which is 2.254 network. If we were not supposed to use VLAN and we're to configure these two networks on separate interfaces on the router, still traffic will be able to travel from a different from network 1 to network 2. So if we ping PC1 from here, it's going to work. 1.1, and it's working. It was taking time to learn the path to travel, for the packets to travel. Now I'm going to do a continuous ping from PC1 to PC2. At the moment it's working. Now routing is taking place on the router, so let me go to the router over here. Now since routing is taking place, if I run the command no IP routing, it means there won't be any routing taking place on the router, and this is a simple command that can change a very expensive router to a very dumb device, because for all we know, and for what routers are being made for, routers are being made to route traffic from one network to a different network, joining two networks together. So if I type no IP routing, you will notice that the ping the packets are dropping from PC1 to PC2, and there we go. The packets are dropping. The packets are dropping because there is no routing taking place between these logical networks, that is from VLAN 1 to VLAN 2. Now, should I do IP routing? the packets should be back and up and running well. So it will take time to converge, and there we go. Our packets are now being routed from network 1 to network 2. So that's how to create router on a stick. Using only one router, you'll be able to configure sub interfaces on the router and put different VLANs all connecting to the router. So that's how to go about router on the stick. Thanks for watching this video, and see you in my next video.